Quantity can be a game changer. When you're making a large quantity of ceramics, prices tend to drop, as with any other product. And that's when it makes sense to invest in some specialised tooling like die pressing or injection moulding. It's best to aim for what we call near net shape manufacturing, getting your ceramic as close to the final shape as possible during the initial process. This is because it saves you grinding, lapping or polishing later on. So whilst green machining doesn't usually break the bank, the final shaping with diamond grinding can be a considerable part of the final cost. Grinding is slow, but it achieves high micron level tolerances that you might need. The tighter your tolerances, the more it will cost. So it's a good idea to keep those tolerances in check and not to go overboard. Less is often more in this game. When converting a plastic or metallic part to a ceramic material, you may require a simplification of the shape and relaxing of tolerances. Remember, the name of the game is efficiency and cost effectiveness. The best ceramic designs are simpler, symmetrical shapes with relaxed tolerances. A ceramic-friendly design will make a huge difference when making ceramics in quantity. What are machinable ceramics and their pros and cons? Popular machinable ceramics include Maycore, Shapol and boron nitride. They're softer ceramics and you can machine them with carbide tools and no post-firing is required. This provides a shortcut to making ceramic parts. With these machinable materials you manufacture components, even complex ones, faster and cheaper, and you don't need any tooling. But here's the twist. The parts might not be as tough as their sintered ceramic cousins. There's a trade-off in some of the properties. These machinable materials are ideal for prototyping and small batches. The properties might even work for your final application. But when you need high quantities, they can get comparatively pricey. So the pricing advantage in low quantities is reversed. So it's a bit of a balancing act. You've got the convenience of machining, but you might have to give up a bit on the properties. It's all about finding that sweet spot between ease of manufacture, cost and performance. How does the design influence the properties of the ceramic? Engineering ceramics are much tougher than conventional porcelain ceramics, but they have their limits. Engineering ceramics are stiff and robust, but they're also sensitive to small defects such as tiny pores. So smaller components with polished surfaces tend to be stronger. Watch out for sharp edges and thin sections. They can be a bit fragile and prone to chipping. Let's talk design. Good design is not just about the ceramic itself, it's also how you put the whole thing together. You want to limit any residual stress, whether from manufacturing or actual use. Compressive stress is the friendly kind. Tensile and shear stresses need to be kept to a minimum. If you want even more toughness, you can choose ceramics like zirconia and silicon nitride. They can take on application stresses really well, and hence you find them in blades, welding tools and jigs, to name just a few. The golden rule is when in doubt, talk to the supplier, who can guide you to the right material and help you craft a robust design. And expect to do some testing in the design phase. It may take a few iterations to find the perfect material and design for your application. What are the typical lead times for manufacture of engineering ceramics? Lead time from ordering to delivery can be an important consideration. Lead time can range from a quick 1 week to over 20 weeks, so that's a pretty wide spectrum. The longer lead times are partly about the factory's capacity and about orders stacking up in the queue, partly all about different steps needed to make the ceramic component. Sometimes there can be a dozen or even 14 steps in the process. Smaller ceramic suppliers might be your go-to if you're in a hurry, especially when they're working with machinable materials or ceramics that come from laser cut or extruded stock routes. In those cases, lead times can be as short as 1 to 2 weeks. If you need new die press or injection moulding tooling, that's a whole other story. Just getting those tools ready can take 2 to 3 months before you even start making the parts. So when you're in the prototype phase, testing and tweaking, a ceramic project can easily stretch out to 6 to 12 months before you're receiving production quantities. So remember, ceramics aren't about speed, they're about precision and patience.